Hello everyone, welcome back to my channel Data Sculptor. Today we will see a cycle company case study. So we have some data, 4 tables for a cycle company. So first table is the stores. In the stores they have multiple columns and some data. The stores data and products, what all products they are selling, the company is selling. The customers, who are the customers who bought their products, and next is the sales. So based on these four tables, we have some data, and let's see what all insights we can generate from this data using SQL as well as Power BI. Okay, so let's analyze the data and see what all insights we can generate, and let's see how these insights can help the company grow its revenue. Okay, so now let's go back to SQL Server Studio first and see it using SQL. So once we do everything using SQL, and then we'll go to Power BI and see how to derive those insights using Power BI. So hope you all interested to look into this. So please click on the like button. Also click on subscribe button for more videos if you are watching it for the first time. So as discussed, these are the 4 tables. Products, first one is the product, and in the product table you have the product ID, product name, category and price. And if you see, primary key is the product ID. So for one product ID there can be only one product ID in the product table. And next is the stores. Store is the location where the company is selling these goods. So in the stores you have the store ID, which is the primary key, the store name, the location and the store type. And next is customers. In the customers you have the customer ID, first name, last name of the customer, age, gender and city. And next is the sales table, and in the sales table you have the sale ID, which is the primary key. It's not necessarily that you need to have a primary key for the sales table, but it's we have kept this. Next is the product ID. So this product ID is based on the product ID from the products table. And next is the store ID, based on the stores table. Next is customer ID based on the customers table. The sale date, the date on which the particular sale happened, and for that particular sale how many quantities are sold and what is the total revenue generated. And the next is the promotion applied. So promotion applied is the values are either yes or no. So this is the data we have. So now with this data, if you see these 4 tables, first 3 tables called product, stores and customers, these are called dimensions data. Dimension data is something where you store a single entity, entire information of a single entity. So example, in this product table, whatever product is there, so this is the data. So for this mountain bike, for this mountain explorer, this is the product name. Whatever data can be there, like what is the category, what is the price of this. And similarly for stores is also a dimension, because based on the store name, what is the particular store name's location, what is that location store type, whether it is physical or online, and more information can also be stored. And next is customers. Customer is also a dimension. So you have the customer ID, the first name and last name of the customer, the age of the customer, the gender of a customer, city of the customer. So basically every customer will have only one age, gender and city. So we can store as much information as possible, and as long as the primary key is not changing. Suppose for this customer ID 1, you can store as much information as possible in columns as long as the primary key is not changing. Suppose if the customer ID, say you have the first name, last name, age, gender and city. If there is any other column, if there is any other value related to customers which is disturbing the primary keys, like if you want to make it multiple rows, then you should not add those columns. We need to keep the columns which is not disturbing the primary key. So these 3 are the dimensions. And the sales table is called fact table, because you have the all the dimension related data in this, and also these are the measure related data or the facts from which you can retrieve the data. First is the quantity sold, next is the total revenue. So based on this fact table we can generate the required or retrieve the required facts. So first thing what I can think of from this, let's see initially first insight what we can derive is or if the owner of this cycle company, what you will be interested is every month how much revenue are they generating, right? So based on the sales date, the owner of this company will be interested to see how much revenue they are generating. So first thing is we'll retrieve the monthly sales, total monthly sales. So to retrieve the month name, this is the function we have to use, the date name of month, comma date at. So this is the function we have to use to retrieve the date name. So as we'll give this as month underscore name, comma sum of total underscore revenue as total underscore revenue from sales group by, okay, what is the total revenue? It's total revenue, right? So it's not an underscore, and group by this entire month name function, we'll keep it in the group by, and order by total underscore revenue in descending order. So why we'll keep in descending order? Because we want the months which are having the highest revenue first till the lowest revenue, and this will give us the date name. This particular date name function will give us the month name. So when you run this is the data you get. So in June you have the most sales, and in March you have March and May you have the second most sale, January, February, like this you have the data for all the 12 months. Okay, so this is one of the metric. And next thing is, suppose if you say you want to group this by seasons, group the data by seasons, right? So how do we group the data by seasons? Say December, Jan, February, and or if you say November, December, Jan, February, say these are winter, okay, and March, April, May, June, summer, and say July, August, September, October, say this is rainy season. Suppose if you want to group the data by seasons and see which season is generating more revenue, so let's see how to generate this. So first thing is, you have retrieved this data. So what you'll do, you'll keep this in a CTE, okay, with CTE as what in the CTE I'll keep this entire data. So in the CTE again, what I'll do, I'll write a case statement, select star from CTE, okay. So column I'll keep case when month underscore name in, I'll write the case statement. So first is what, November, December, Jan and February, right? So November, December, so November we'll need to write the entire names, November, December, January, February. Then it is winter, okay, and the same way you need to write one for summer and one for rainy as well. In summer we decided March, April, May and June, right? So March, April, May, June, then summer, okay. Else it is we can directly use the else statement because all the months are covered now, or rainy. End as season, okay, end as season, comma total revenue. So if you run this and also let's keep the month name for to get better understanding, month name, comma total revenue, okay. So when you run this, you also get in the CTE you need not use the order by clause. So here we have to use the order by clause, order by total revenue in descending. So when you run this, you will get together with this data, you will get the season as well, summer, winter and all. But if you want to but for summer, winter and rainy, if you want just 3 rows with the data, what we have to do, so now instead of we have to remove the month name, and here in this we have to give the total revenue, sum of total revenue as revenue, and it is grouped by this case statement, entire case statement you will write, okay. And again order by revenue in descending. Okay, when you run this statement, you see in summer you are generating the most number of sales, around $21,200. Next is in winter, and next is in rainy. This makes sense because in the rainy season most of the people might not buy vehicles because it's difficult to go outside. In summer and winter, in summer people have holidays and they'll buy all the cycles. The kids will buy all the cycles required, and in winter also they'll buy. So this makes sense. So this is one of the insights which you can generate. Group the data by seasons. Okay. Now we have got this one insight. Now let's see the next insight. Okay. Now let's see at product level. So product level, you have you have product ID, product name, category, and price. Okay. So we can generate multiple insights like which product is generating more sales, or more than product name, we can see which category is generating more sales. Okay. So now let's see category generating the most sales, generating the most sales and the most orders as well. Okay. So most orders also I get because there can be a case where here if you see the cost, mountain bike is having 1200. Okay, but hybrid bike is having only 850. So if you buy 5 hybrid bikes or around 5 hybrid bikes, it can be equal to almost 4 mountain bikes. So we want to see total revenue which particular category is generating the most, and total sales, total quantity sold, which category is getting the most. Okay. So then now what we will have to do, first simple select query only, select from sales A, left join product B on A dot product ID is equal to B dot product ID. Okay, and here we can do B dot category comma sum of sales, sum of total revenue as revenue, group by category, and order by to descending order. Okay. So in this way we will get which category is generating the most revenue. Mountain bike is generating the most revenue, hybrid bike is second, and road bike is third. So from this data what you can understand, so people who are more interested, in mountain bikes, and people are less interested in road bikes, and that's what the revenue it is generating. That's what the stats is showing. And next is category generating the most items sold. So simply the same measure I will copy, the same query I will copy, but here if you see in the sales table you have one more thing called quantity sold. Okay. So instead of total revenue I will just sum that quantity sold value. So sum of quantity sold as items sold, and if you run this, if you see so in this if you run both the queries together, you will see mountain bike is generating the most revenue, whereas hybrid bike is having the most number of items sold. Okay. So this is how the insights will be generated, and the owner will see what all decision he has to take, but one decision he can take is the road bike is generating less revenue, so he has to think on how to promote his road bikes so that revenue for road bikes also will increase. Okay. So this is one of the insights, category generating the most, from product level we have retrieved some information required, and next is the store level. So in store you have store ID, store name, location, and store type, right? So let's see which location is generating the most number of sales. So again the query is almost the same. I'll just copy here, copy this, and instead of product, let's see, we have to use the store location, store location generating the most revenue. Okay. So instead of product I'll use stores, and here it is store ID, and also here also it is store ID, and here it is location, and if you run this You see, Denver is getting the most generating the most revenue, whereas New York is generating the least revenue. So now they have to think how to promote their company. So based on the sales data, they'll take this decision where to do the most number of promotions. So most probably they need not promote much in Denver because it's already generating most revenue. So they have to keep more efforts in these three areas because it is generating the least revenue. So this is how the companies will decide how to promote where to promote their items. Okay, this is one insight which you can generate. So from location, store also we have generated. There can be other things as well, like a store type, whether we can select online, whether online sales is coming more or offline sales is, physical sales is coming more. That also you can select, but here in the data you see only one online store, so obviously this will generate less data. And even if you see online, you have here, this is fifth, so this is fifth row. So obviously physical sales are more than online because people will come and see, because when they are buying these things like cycle and all, they will come and see to the store, come and see in the store directly and buy it instead of going through the online route. So this is one insight they can which they can generate. And next is the customers. So customers, you have the ID, customer ID, first name, last name, age, gender and city. Okay, so based on the customers data, you can see which age group is buying the most products, and which gender is buying the most products, and the location of the customers where they are buying the most products. Okay, so from customers you can retrieve multiple informations. So first we will see age group having the most sales. Okay, so first we will see what is the age group, then we will try to categorize the age groups. Select star from customers. So you have age group 20. Okay, let's do an order by age. So based on this we can know the age 22, 25, 28, 39, 29, 30. In this way it is. So if you want to write any logic saying so from 22 to 25, if they are one particular category like students, on 28 to 30 like adults, like this, whatever logic you want you can write based on the age. For now I will not write any logic, but this is something which you can generate as well. Okay, let's write a logic, say from categories, say from 22 to 28, I'll keep the category as A, and 29 to 35 category as B, and again 36 and above let's keep category as C. So I am just keeping ABC as random values because people based on the original sales they can categorize the customers, but I just want to show you how categorization will be done, so that it's just an example, right? So we are just keeping it as A, B and C, but in general, in reality, customers will keep some categorization, like if they are students or if they are working employees, something like this. Okay, so select from this is the same query almost, and here instead of left customers, stores will reuse the customers, and this customer ID, and here we have to use the case statement, case when age greater than or equal to 22 and age less than or equal to, okay, otherwise let's use the between operator between 22 and 28, then A, and again between 29 and 35, then B, and again age greater than or equal to 36, then it is C, and as we will keep this as age category. Okay, and we can use this case statement in the group by. And if you run this, simply you will get category B is generating the most sales. That means people who are aged between 29 and 35, they are generating the most sales. And category A, which is between 22 and 28, they are generating the least sales. Okay, so based on this age, again they can do, so 22 and 28 means they are mostly at the younger side, younger people, so or mostly people who are studying and all. So they need to introduce new schemes, like for student. If you see in Amazon Prime or in some other things, they introduce something called student scheme, right? For students, they'll reduce the amount or provide some memberships, free access or something. If you see a lot of places where for students you'll have free access and all. So maybe based on this revenue also they can introduce some schemes. Okay, this is one age group insight generated using the age group. So now let's see after the age group, let's take gender as well. So gender making the most sales. Okay, so again the same query from the sales only, and here it is gender, and again the customer ID only. So here, sorry, here also customers. So this is also customers only, not gender, my bad. Okay, so based on the gender, okay, it's total revenue, right? So when you run this, you will get which gender is generating the most sales. So if you see female 26,000 and male it is 24,000. So if you see it's almost the same. So from this particular gender, based on the gender you cannot derive any insights, because the difference is almost the same. Means not much huge difference. So if you see it's almost 50-50 or it's like 45-55 something, almost the same. So they need not make much effort over here. Like suppose if there might be a scenario where males might be having most revenue or female might be having less revenue. In that case again they might introduce new schemes for female. If you are a female customer, you can get this particular discount and all. So maybe they can generate, but based on the insights you derive, you see that male and female are almost generating the same kind of revenue. So they need not take much. So basically here there is not much insight over here. Okay, so this particular insight doesn't make much sense for them. Gender is not playing a role here. And next one is city, customer location. So again I copy this same, and customer location, and here it is city. So again New York is generating the most revenue and Los Angeles is generating the less revenue. So here in New York, customer location, people mostly in New York, they are buying the products compared to Los Angeles and Boston and Chicago, these areas. So here based on this, I think the company will take some decisions, like maybe they'll open new stores in Chicago, Boston or Los Angeles. So if you see the store location also, you have the store location you have in Los Angeles, Boston and Chicago. Since it is generating less sales, they'll have to see how to improve this business, maybe by introducing more schemes in these locations, or say more I mean they'll take based on the decisions, whatever they want they'll take. But this is the insight. Our job is just to provide these insights. Based on the insights, the team will take the required decisions. So these are the few insights which are generated for this. Just if you see, it's hardly a 30 row data for sales. Only for this particular amount of data only we have generated a lot of insights. So around 1, 2, 3, 4, 5, 6, 7, 8 insights we have generated. So I hope this is helpful for you using SQL. So now let's see how to generate this same, how to create charts and how to play with Power BI and give So that, I mean, every time we need not, whenever the new data is generated, right, every time we need not, we should not run the queries. Or say if there are some non-technical persons who want to see the insights out of the data, they'll not go and run these queries, right? So that's why we use some reporting tools like Power BI. So now let's see how to create some charts using Power BI. So I have already imported the tables in Power BI from the SQL server I have shown, and this is the relationship, one-to-many relationship between the dimensions and the fact tables, one-to-many single direction relationship. And now let's try to generate the same insights in Power BI as well. So the first insight we have generated is monthly sales, right? So if you see in the sales table, you have, first thing what we have to create is create two measures. New measure, total revenue, total revenue is simply sum of sales, sales of total revenue, right? So this measure will give us the total revenue. Total revenue is already okay, so let's keep total underscore revenue. So total underscore revenue one measure is created, and similarly we will see total new measure, total items sold. Sum of sales of quantity sold. Total items sold also we have created this measure. Okay, so first thing we have seen, based on the sales date, based on this month, we will drag the month here, and let's drag the total revenue here, and we will see which month is generating the most sales. So here sort by total revenue. Okay, so in this we will know which month is generating the most sales. So again, as we have discussed earlier, right, like create for every month we have created a season in SQL, right? So you can do that here also. So if you go to the, we can create calculated columns in sales table. So if you go to the sales table, and here if you see we have the sales date and all, we can create a calculated column and do that, and just based on the new calculated column you can directly use it in the table. Okay, so this is one chart, or we can either use a pie chart. So in the pie chart, if you see, it's not giving much insight, right? Almost everything is having the same pie, so it's better to go with table only here. Okay, and next thing is we have checked by product, right? So product, category, and sales, total revenue. So if you see this one also, now let's create a pie chart here, pie chart. So if you see here in the pie chart, based on the percentage, if you see 19.8% sales is generated by mountain bikes, and 14.4 and 14.4 K is generated by road bikes. This is one insight. And next thing, from apart from product, we have seen the stores. So based on the store location, we have used the total revenue as well. Okay, so here also let's use a donut here, donut chart. So donut, if you see in this, Denver is generating the most sales, because just by the sizes, and here also you also have the percentage here. Just by the initial glimpse, you will see this is having the most sales, right? So you can just hover on it and see which one is, what is this location and all. Or otherwise, what you can do, you can create one more, say you can create some bar charts as well. Sorry, yeah. If you see it here, Denver is having the most sales. So based on the bars also you can compare here which city is having the most and all. And this is one insight. And next thing is, other than location, we have three with customers as well, right? So based on the customers, so customer age and sales revenue. So again, here also I'll use a bar chart. okay, or yeah, this one maybe we'll use. And if you see, it's not coming properly, right? So the age is not coming properly, so we have to go here and change the setting. X-axis instead of continuous we have to keep categorical. So if you keep it categorical, we'll get the required output. So 29 years of age, people whose age is 29, they are generating the most revenue, and 31 years generating the least revenue. And again I'll copy this, and here instead of age, say I'll keep city. So again New York is generating the most. If you compare store location and customer location and store location, there is no direct relationship, right? So maybe here people from New York are coming to Denver and buying the products, or something like this is happening, because here New York stores is having the least generated the least revenue, whereas customers in New York have generated the highest revenue. So that means these New York people are not buying in New York stores; they are going to other cities and buying. Okay, so the company people need to see why it is happening. And yeah, this is some charts. I mean, although it's not neat and all, but you can format it properly, and you can use some filters as well. Suppose if I want to say apply a filter, if I want to apply a year as a filters on this page. If I keep year, okay, it's only 1 year, so it will not make sense. But say if I want to have some other filters, say customer gender as a filter, you can keep. So based on gender, suppose if based on gender, you can see, I mean, if you want correlation, right? So gender and month. Suppose if I want gender and month, multiple correlations. Say if you want to combine customers and products data. Suppose if I select male here. So in this, if you see males, they have generated most revenue in January and least in September. And if you select female here, female has generated most revenue in June and least in April, right? So based on the gender also you can see the data. So you can apply any number of filters here. So first is the gender, you can keep, and next is store location also, and from products you can keep the category. So with this, what will happen, you can do correlation between multiple dimensions, like product categories with gender, or say product categories with customers and all, and customer city and all. You can do multiple correlations. Even in SQL you can do those, but in Power BI it will be more easier to understand. So this is one such example where you can use both Power BI as well as SQL to generate insights for a small company. So hope you all like this video and explanation. So if you like this video, please click on the like button, and if you are interested to analyze more case studies, you please click on subscribe button, so that because in future I am planning to do more case studies. And also, if you feel free to you can use the comment section, and based on the data you can comment out what all additional insights which I have not shown can be generated. So thank you, have a nice day.